Today I am replacing the primary coolant tank, aka the high temperature coolant tank, on this 2022 F90 M5 competition. This is an LCI model, and this particular vehicle has been in winter storage, hence the reason it's positioned on the lift and connected to this C-Tech lithium charger. Please excuse this extremely dirty F30 328i X-Drive. This vehicle just came off of an 1,100 mile road trip, and it is in desperate need of a wash as well as detailing. So what are we talking about today? Well, the issue at hand is something that's prevalent on most new F90 M5s, and how far back in time this goes, I really don't know. I wish I had that information. I'm sure BMW has that information, but it is definitely an issue that is prevalent on newer M5s. I don't know if it's just the LCIs or, again, how far back in time it goes, but this is something to look at if you have one of these vehicles. The vehicle has 3,500 miles. It is effectively new. Let's get started. First of all, I have the engine cover removed. It's held in place with these 4 plastic dowels, and I also have the DME cover on the driver's side removed. The cover looks much like this cover on the passenger side, and it's held in place with these 4 snaps. I removed those items to get a better look at the issue at hand. The issue relates to the primary cooling system tank, which is located here. However, I should clarify something before moving on. This engine has split cooling systems. As with most turbocharged engines in the BMW lineup, there is 2 cooling systems. And in this case, this tank serves the engine block, the heater core, and the primary radiator. The tank on this side of the engine supports cooling for the turbochargers as well as the DMEs, and it utilizes the outboard radiator, so the smaller radiators that are to the left and the right, so the one that you would see here as well as over here. Okay, we're not concerned with what is called the secondary system. We're concerned with the primary system, and specifically this tank. This is the point or the issue at hand. What is occurring with these tanks is that they are leaking, and if you can see, I'm going to put a spotlight on this here, you can see around the edges of the tank here there's some residue. That's actually coolant residue, so it's kind of white, yellowish, crusty. And then if you look further, you can see where coolant has leaked down the side of the tank. There's some drip lines or runs there. It's not actually wet, that's all dried up, but the issue that this creates is that the coolant that leaks out of this tank, it goes down into the fuel injectors or to the coils, the coil packs. That will eventually create an engine fault of some kind, warning on the dash, misfire, what have you. This has not occurred on this vehicle yet. I'm addressing this earlier than most owners because I'm aware of the problem, and I don't want to get into a situation where it's misfiring or some other components are damaged as a result of this. This tank is 2 pieces. It's a bottom piece and a top piece, and they're fused together. These tanks, when they heat up, they expand, and then that's when the leak occurs. And it's unfortunate, but it's occurring on most M5s in the field. So what has BMW done about this? Well, they have revised the tank. There is a different part number for this. I'll put the part number in the description. If you have a 2023 at some point, they've cycled in the new tanks. This is a 2022. They were still using this older part number, this older style of tank. I have chosen to replace this tank on my own. And I could very easily take it into the dealer for warranty work. They would take care of it. However, I don't have or have not had good experiences. It's not very expensive. Retail on this tank is about $160. You can get it online for about $130. Why did they put a tank on top of the engine like that? Or why did they put 2 tanks on top of the engine? Well, it's all about packaging. They just don't have room in this engine bay to do anything different. Now, the F10 was different in that the tank didn't sit atop the engine here on the driver's side. There was a filler neck. Again, it was back in here. But this is a completely new design. They changed things up. This is the S63 B44 T4 That was the S63 B44 T1. So we're talking about 3 generations later. And no, my math skills are not mistaken. They actually didn't have, they skipped over the T2 or the T3, whatever it was, but this is the T4. The coolant tank has arrived. I placed the order 2 days ago, and the tank was delivered to a local BMW dealer. Now let's have a look at the tank. Removing it from the box, it is identical to the other part. Now this is a revised part number, and I presume something has changed. Let's move the box aside for just a second here so we can get a better look at this on the bench. I'll turn it around, and the tank is, yeah, all the ports are the same. Everything looks relatively unchanged. I'll do a side-by-side, but we're going to make sure that this tank does the trick and it does what it's supposed to do. We will get the old tank out, and the first step of that process is to drain the cooling systems. Unfortunately, there's no easy way to, it would be great if you could just siphon the fluid out and then swap tanks, but you would have to get the fluid removed all the way down into this neck and into that bottommost hose. That's not going to happen. There's no way to get a piece of tubing into that space. Okay, let's quickly review the tank one more time before we get started. The tank is held in place with 2 T30 Torx bolts, and once you remove these, then there are 2 plastic dowels on the bottom of the tank. They're probably in some type of rubber isolators or something like that, and the tank will pull straight out. The tank has 2 small hoses. It has a 3rd larger hose on the bottom, and that will be more easily accessible once you loosen the tank, and you can raise this up just a little bit, and you'll be able to get to that clip more easily and get that off. And then of course there's an electrical connector here. It's probably the level sensor in the rear. That is effectively it. What you're going to want to do, first of all, is remove the cap, and don't be one of those people that leaves the cap under the hood somewhere and you put the hood down and, you know, ruin the hood. You want to put this aside. So that's really it. I could just get a little bit better look there. Okay, you can see fluid's down just a little bit. It's lost probably, I don't know, maybe a Dixie cup in a quantity, something very, very small, but we're going to get this out of here. The forwardmost undercover or under tray beneath the engine has been removed. It is held in place with 18 8mm screws, and let's take a look underneath. So this is all very similar to the F10 M5. This is the oil cooler. What we're now looking for is a lower radiator hose. Now, that's the problem when you've got a lot of compact items under here, and that connector there, no, that's a no-go. Don't want to touch that. There is nothing you can see from beneath. We actually have to go above. But I wanted to show this. I want to make sure people understand that, you know, this is a bit of a trick. There is not a lower radiator hose per se, or not one that stands out when you're underneath the vehicle. We'll go up top and take a look. This next step is optional, thus you do not have to do this. I have siphoned as much coolant as possible out of the coolant tank, and I've done so using this siphoning tool. Very simple, very straightforward. I removed probably on the order of about 2 quarts of coolant. That's not very much, but my perspective is I'm going to remove as much as possible before removal of the tank. It just makes things cleaner and neater. Now, keep in mind, the tank itself, looking at the new tank, it's a series of graduated compartments. So when you siphon, you can't get into every one of those compartments, but you can get most of the fluid out. Again, not a step that's necessary, but a step that I've chosen to take. Moving on. We know from looking from below the vehicle that it is not possible to get line of sight to the lower radiator hose or the connector. We'll now take a look from above. I have focused light on the connector, and it is located here. It's not easy to get a camera into this space, but that is the connector. And the question now is, with all of the wiring, plumbing, structure, and mechanicals, how do we remove the connector to perform a coolant flush? The answer is, we'll start with removing this air box. So it's very straightforward. Disassembly of the air box requires removal of these hose clamps, as well as this structural support or strut bar, which is also integrated with the air box itself. There's a 16mm bolt here, as well as an 18mm bolt right beneath this C-Tech charging clamp. And you also have to pull this panel out, but that's very simple. It's just held in place with these push pin connectors. Remove this, remove the bolts, loosen and remove the bands, and then the box, the air box itself, pulls straight out. It's held in place with siliconized rubber grommets. I'll show those once I get the box out of the vehicle. The air box is now removed and we can access the lower radiator hose. Before taking a look at that, be sure to unclip this hose from the side of the air box. Moving on, I have some light in this space and I'll try to get the camera as close as possible. That is the hose in center frame. This is the connector, and on top of the connector is the retaining clip. So you want to pop that and pull the hose back. If this air snorkel is in your way, you can actually unclip it and pull it out. I think I'll probably leave it in place. It's not bothering me. Below that is the pump, which we could see below, but we could not see the lower radiator hose or connector. And yeah, we're going to get all of that wet when we pull this hose, which is unfortunate, but that's the way it goes. So that is the next step to start the draining procedure. The lower radiator hose connector has been loosened, but not fully removed. Reason being, I don't want a flood of coolant going in every direction. And I have a lot of towels and plastic that I've put in place, even some bubble wrap, I had that handy here, to divert coolant away from the front of the engine and from other electronics and things like that. Now granted, this area of the engine gets wet regardless when driving. I'm just trying to minimize the residue from the coolant and all that nastiness. That's what it looks like right now. I will run several gallons of distilled water through the system to flush the system, and then I'll pull that hose out a little bit further. I will siphon the remaining coolant water mix from the bottom of the radiator. Again, the lower radiator hose, it's not on the bottom, it's actually in the middle of the radiator. So I'll go down to the bottom of that tank with a rubber hose and siphon that out to completely evacuate the system. This is a brand new vehicle, so this is really overkill, but I'm going to treat it as if it were a normal coolant flush. I should mention that this methodology does not follow the BMW TIS service instructions for a coolant flush. They would like you to remove this metal panel, as well as the plastic cover on the driver's side, the driver's side air box, this metal structure, aluminum structure here, as well as the electric radiator fan and the drive belt to the engine. To me, that seems like overkill, and I understand why they recommend doing those things, because most likely in a service environment, there's going to be some sloppiness. There's going to be situations where coolant gets on the drive belt or on the pulleys, and it's untelling what might happen. But in this case, I've taken preventative measures. I put plastic in place. I've not just pulled off the hose and let coolant fly in every direction. They also, in their instructions, they want you to remove the upper radiator hose, which is really not necessary. It's really not warranted to go to that amount of trouble. This might be a minimalist approach from some perspectives, but it's one that works. It's exactly what I did on the F10 M5, and that worked out beautifully. The cooling system has been drained and flushed using 4 to 5 gallons of distilled water. The crazy ensemble of plastic that I used has been removed, and the lower radiator hose has been reinstalled. making sure that the connector snaps. That is, the snap has to be lowered and you must hear an audible snap, otherwise it will back itself out. Where do we go from here? Well, first of all, I'm going to elevate the vehicle as well as rinse off the bottom areas where the coolant was running down. And as you can see from above, there's little to no places that are wet. Everything looks pretty good. I mean, that pump got showered with coolant, but doesn't look too bad right now. There's a few drips below, but the plastic I used kept most things dry. As I stated, I'm going to flush the bottom of the vehicle off, and then I have a Master Blaster forced air, heated air dryer that I'll use to completely dry this area before putting everything back together. Okay, the bottom side of the vehicle is quite wet, and that's because I just sprayed this down with the horse sprayer to get as much distilled water into these cracks and crevices and chase away the coolant. There was no real visible coolant remaining because I put so much distilled water through the system. Here it is. That's 5 gallons of distilled water and roughly 2 gallons of 50-50 mixed coolant that's drained from the system. Again, this is the HT12 green. What I'm going to do next is lower the vehicle and use forced heated air to chase away any remaining water from above, and then I'll raise the vehicle up and do the same thing down here, focusing on getting all of this dry. And yeah, it's turned out really well. Off camera, I lowered the vehicle and I used the heated forced air dryer, and then I raised the vehicle again and cleaned up everything on the bottom. It looks really good. The dealer would never take pains like this to clean things up, and now we will begin to reassemble and reinstall the airbox and get everything back together, and then I'll go through steps necessary to refill the cooling system. The passenger side airbox has been reinstalled. Everything is tightened, and on that note, the bolts securing the strut bar slash airbox support should be properly torqued. The 16mm bolt beneath this plastic shield, which again secures the strut bar, that is 28 Newton meters or 20.66 foot-pounds. The 18mm bolt on the strut tower here, it requires 56 Newton meters or 41.3 foot-pounds. So make sure that those are torqued properly. The rest is fairly simple, fairly straightforward. I will say that if you have trouble getting the airbox back in place, simply remove the top of the airbox and install the bottom first, then the top. Sometimes these things can be a little bit frustrating to get aligned properly and get it tied back into the, or clipped back into the air snorkel below. That's one way to get around that. So what's next? We're going to take a look at the coolant required for this process, and then I'm going to start the coolant refill itself. Be aware that you do need a coolant evacuation system, aka a Venturi system, to do this. These systems do not allow you to pour coolant into the tank and run a purge process. Rather, you need the evacuation tool to do this properly. So we'll move on to the next step. Before beginning this procedure, we should talk about which BMW coolant is used in the F90 M5. On the left, we have the G48 blue coolant, which BMW has used for the last 30 plus years. If you're a DIYer, you're very familiar with this. On the right, we have the HT12 green coolant, which came into existence in the 2018 timeframe. I have seen a couple of 2017 BMWs with this green coolant. Thus, it was already out in the wild, but it went mainstream in 2018 and beyond. The coolant on the left is what you'll find in the F10 M5. The coolant on the right is used in the F90 M5. So what are the differences? Well, both are environmentally friendly coolants, but the one on the right is more so. On the left, the blue coolant is nitrate, phosphate, and amines free. The green coolant on the right is nitrate, phosphate, amines, and borates free. It also has added corrosion inhibitors. HT12 coolant is backwards compatible, thus it can be mixed with the blue G48 coolant. However, BMW recommends using only HT12 in 2018 and newer vehicles that came from the factory with the green coolant. One final comment, HT12 coolant is available from other manufacturers. Valvoline is one of those. I think there is one or two others, but it's not easy to find. We are using genuine BMW coolant to complete the process on this F90 M5. Jumping straight ahead, I am preparing to refill the coolant system. I'm using a Schwaben coolant evacuation system. This is a necessity. You don't have to use this brand per se, but you do need one of these systems. Again, this cannot be done without a coolant evacuation system, what is also known as a Venturi system, or a system that uses the Venturi effect. We have the system connected to the compressor, and I also have my tank of 50/50 premix here. This is a nice tank because it's semi-translucent, so I can see where the coolant pickup is, which is right there in the bottom. And we have this primed. We've only got one little air bubble there. That's not going to be a problem. And we have the system depressurized to somewhere between 30 and 31 psi. So 31 is about as high as I've ever seen. So that is a good place to be. Now, this is not a step-by-step on how to use a coolant evacuation system. If you would like instructions on how to use one of these systems, there is a video on this channel. It is 330i X-Drive, pre-owned, post-delivery, preventative maintenance, part 2, and that goes into the details of how to use this system. I'll hit the high points. This hose is used for any discharge that may occur during this procedure, and we're all set. So I'm going to open this one more time, see if I can get that needle to move just a little bit. Seems like it's holding. I'm going to close that off, close this off, and I'm going to open this valve to begin the process. And I'm going to watch the coolant very closely in this tank, because we don't want that to run dry or to get down below the pickup. Again, the pickup is in the bottom corner, so I think we're good to go. And opening this a little bit more, you can see the coolant go down, and I'm going to stop it right about there. Okay, no air in the lines, no issues. What I will do is go ahead and bring the level of coolant and 50/50 premix back up to the top, and we'll resume, but I do have to pause and put the camera down for a couple of minutes. The tank is once again full, and we'll resume where we left off. Ideally, it would be best to use a tank that is 2 to 3 gallons instead of a 1 gallon tank like this, but this is what I'm working with. It's always worked for me. So again, we're going to open this valve, and we're going to watch as the coolant goes down in the tank. We're now down below 10 psi, but we're getting really close to that pickup. I wonder if we're going to make it. That's it. That's all it's going to take. I'll shut the valve off. We will, off camera, I'm going to remove the air hose, and then what I'll do is I'll backfeed some of this coolant out of this line into the tank, draining this line effectively. And then what you have to watch out is when you remove this, it's going to be, the tank will be completely topped off, which is not where you want it. You want to siphon fluid out, bringing it down to the max level, and then run the coolant purge process, which is another step of this project. But I'll do that now and we will move on. As a quick checkpoint, I allowed the vehicle to sit overnight after refilling the coolant. That allowed me to check for leaks or to see if anything wasn't sealed up properly. Everything looks good. I'm going to go ahead and move forward with the coolant purge process, and we'll get into that now. To begin the coolant bleed process, first make sure that your heater controls are set to maximum. So they should be on 84 degrees Fahrenheit on both sides, with the fan speeds on both sides set to minimum or low. You'll want to then put the vehicle in diagnostic mode. You'll do so by pressing the start-stop button 3 times very quickly. The steering wheel will lower, and after a few seconds you will see a message in the center of the IP there. Diagnostic mode active, we're good to go. At this point you'll press and hold the accelerator pedal for 15 seconds. You will then hear mechanical noises under the hood, at which time the process has started. You'll remove your foot from the accelerator and then start the vehicle. Keep your feet off of the brake, keep your feet off of the accelerator, and allow the vehicle to run for a minimum of 11 minutes. There are no messages on the instrument panel, at least in the LCI models, that tell you that the process has started or the process has ended. But I did allow my vehicle to run for about 13 to 14 minutes. They say the process completes in 11 minutes, but again, there's no indication. There's nothing on this display that tells you that. I think the prior pre-LCI vehicles may have actually provided a message. This vehicle did not. During this process, the vehicle will change RPMs. It will do a number of things. You'll hear things. That's all normal. I'll provide a snippet or two of what happens during the process. This is an example of what the vehicle does during the purge process. I'm not revving the engine. The diagnostic system is doing this. Again, not me. The initial bumps in RPM were around 1500. Now it's going up closer to 3000. The process runs for 11 minutes. We're now 5 minutes into the process. I put down the windows because during this process you are running with the heat set to maximum and the fan on low, so it gets kind of warm in the car. When the process completes, you simply turn the vehicle off and allow it to cool down. Okay, the vehicle is off, and I'm just going to leave the vehicle for a couple of hours. Moving on to the final step of the process, the coolant is at the max level in the tank, and over here I have 200 milliliters of additional coolant. This is the manufacturer's recommendation to add 200 milliliters of additional coolant after running the coolant purge process. Off camera, I ran the process 2 separate times. I've taken that as far as necessary. Now I will add the coolant and complete the process. Let's get the funnel in place and add the remaining coolant. Got some paper towels and additional towels on hand in case I make a mess or we have an overflow or something weird. Again, you do not want to overfill the coolant expansion tank, otherwise that negates the purpose of the tank. And let's now have a look and see where the coolant is. It really doesn't look much higher, and that's it tells you there's a lot of additional capacity there in the tank. Sorry for getting my hand in the way. It doesn't look like it's much higher. 200 milliliters of additional fluid is the recommendation, and I'll check it after driving the vehicle a few times and see where we're at, if I have to siphon some off or what have you, but it's likely not going to be the case. In closing the video, this was a very straightforward project. If you have a new M5, particularly the LCI model, you will likely need to have the high temperature coolant overflow tank changed. This is, for you, a warranty item. You can take the vehicle to the dealer. I, however, will not take my vehicles to the dealer for anything if I can prevent it. With all of my BMWs, once they're in my possession, the dealer never lays a finger on them. That is my perspective and my methodology on caring for my own vehicles. You may have a different perspective. I'll also say that there's a lot of opinions out there about BMW plastics and failures of this kind. And while this was very unfortunate and should never happen on a new vehicle, it does. And it happens because of suppliers. BMW is not vertically integrated. They depend a lot on suppliers. And if you are of the belief that the plastics on BMWs are the only ones that fail, you haven't worked on Mercedes, Audi, or Porsche, because the same types of things with plastics under the hood occur on those vehicles. As I stated, it comes down to the types of materials that are being specified by the manufacturer to these suppliers and what the suppliers are actually delivering. And this wraps up the video. I hope this has been helpful. If you have questions, drop me an email.